Swayam Prabha. Digital India. Educated India.
Good morning. Once again welcome to this course, and perhaps you all remember I have completed compressibility and settlement and all aspect of the compressibility and time rate of settlement, derivation, relevant formula, all I have discussed, and I will now try to show the application. That means, how different types of calculation you have to do for finding out the amount of expected settlement, particularly here consolidation settlement, and at the same time what is the time required to complete the consolidation settlement. And few small example perhaps I have taken, and now again, and there are different ways actually the question can come, and particularly in the competitive exam like GATE and UPSC and many other exam. So, I will try to spend about an hour for to show some different applications on consolidation, competition, and time rate of settlement. So, I will start with the first one. This is the problem description. During a pressure increment, a consolidation test sample attained 25% primary consolidation in 5 minutes with a mean thickness of 18 millimeter. How long would it take a 20 meter thick layer of the same soil to reach the same degree of consolidation if the layer was drained on both surfaces and it was drained on the top surface only. So, this is the problem perhaps I have discussed before also, that there are two different ways it can be solved, and if you can take one consideration, then very quickly you can do, and if you do not even consider that particular consideration or observation, then also you can do it, but it will be little lengthy. So, I will do both ways, and here actually what is the important point you have to observe here, that a sample collected from the clay and its consolidation is done, and it took 25% consolidation. To attain 25% consolidation, it took 5 minutes, and generally consolidation settlement when you do in the lab, it is draining in both sides, and so your thickness will be just half of that. And now, in the actual field, the clay is of 20 meter thick, and it can have two options, either drained only at the top and drained at both sides. So, you have to find out now the same amount of degree of same degree of consolidation, to achieve same degree of consolidation in the field of 20 meter thick clay layer, when drained in one side and when drained in both sides, how long it will take. So, that is the question. Now, here what are the observation you have to note, that is actually, see, the soil is same. So, in both cases your CV will be same, supposed to be, because it is the sample is collected from the clay layer. So, it should be representative value, same CV will be there, and at the same time both soil is achieving same degrees of consolidation. That means, suppose 25%. So, time factor T 25 for field and T 25 for the soil, these two time factor will be equal. If the time factors are equal and time factors are equated or correlated or is related to CV, time required to achieve that much of consolidation, and thickness. of the drainage path. So, you can express T1 for lab and T1 for or T for lab and T for field, both we can express, and both the T seen is equal, and then if you equate them again we will see CV will be also equal. So, if you take that observation, then ultimately you will have 4 variables, the time for lab test and and thickness for the drainage path for a lab and time for field to reach that much of consolidation and thickness of the drainage path in the field. So, these 4 will be there, out of 4 3 will be known, 1 will be unknown. So, this can be done very easily. If you note this observation, then only this is the way very easily you can do, otherwise also it can be done. I will show both way. That means, if I do not consider that based on laboratory information, I will find out what is the CV value and use CV value and find out what is the time required for the laboratory or field soil. So, both way I will do. So, first step 1. So, I will take the first one by first method, that is your, you can see, as I have told you, the laboratory sample, suppose I will say this is T for laboratory, and that will be equal to CV T by H square. And for field also similarly, suppose this is also T equal to CV T. So, this is suppose T lab L suppose, and this is suppose T field, and this is suppose H field square and H lab square. So, now this, since we have mentioned that same degree of consolidation, how much time is required, here actually time required is mentioned and here time is not known. So, these two are equal, then it will have CV T L divided by H L square equal to CV T F by H F square. So, again you can see CV both same soil. So, CV will be equal, that gives you T L by H L square equal to T F by H F square. So, actually T by H square equal to T 1 by H 1 square equal to, this is the, when this type of problem, this can be remembered as a formula, and if you can remember this formula by simple calculation one can do, and you can see you have your laboratory average thickness is 18 millimeter. So, H L generally in the lab it is not mentioned, otherwise generally it is mentioned, otherwise also you can assume H L will be, since 18 millimeter is there. So, it will be 18 by 2 millimeter, and problem is given for 2. First one is drainage only at surface, drainage at the surface. So, H F will be equal to 20 meter itself, and since it is in millimeter, so it is 9 millimeter. So, here also I may express in 20,000 millimeter. Okay. So, then your calculation will be that is T field will be required, T field will be equal to T L into H F square divided by H L square. So, this will be T L is how much? It is 5 minutes, 5 minutes, and that will be equal to draining when draining in one side, it will be same. So, 20,000 square, and this is actually 9 square. So, this actually this unit become it minute. So, this again I can divide 5 into 220,000 square divided by 9 square into 1 by 60, then become hour, then it become 1 by 24, it will become DA, then 1 by 365, that become year. So, if I do this calculation, it comes finally 47 years. So, if I take drain at the surface only, one side, one way drainage, I do not know, I will see the problem is given whether reverse, that to be noted. This is specifically I have mentioned when drainage is one side, this is the answer. Now, I will say drainage in both side, that means if the clay layer is here and this is draining layer, this is also draining layer and this is 20. So, your drainage path will be half of this. So, this will be 20 by 2 equal to 10 meter, and your T lab by H lab square equal to T field by H field square. So, T field will be equal to T L into H f square by H L, again same square. So, this will be equal to 5 minutes and this will be 10,000, 10 meter means 10,000 square divided by H L will be 9 millimeter. So, this will be actually in minute. Now, again I can do 5 into 10,000 square divided by 9 square into 1 by 60, that become hour, then 1 by 24 become day, 1 by 365, that become year. So, if I calculate this one, you will get the answer as 11.7 years. So, you can see now difference, the 20 meter thick clay layer, if it drained in one side, then it takes 47 years, and if it drained in both sides, it is taking only 11 years. So, this is the way, and this problem I have shown here in when a sample is collected from a lab, a representative sample, and tested, and a particular degree of settlement time is known, and then if it is asked to achieve same degree of consolidation in the field for that much thick of layer, then what observation we are taking, that time factor for both case T lab equal to T field. This is the one if I do, and then from that I get this one, and if I take this one, the calculation is one step. But if I do not do this, then alternative, actually there is a alternative can be is there, you can do this way. See, the laboratory actually 5 minutes for achieving 25% degree of consolidation. So, u here 25%, okay. Then T 25 will be equal to pi by 4, and that is actually pi by 4 u by 100 square. So, that means pi by 4 into 0.25 square, and that gives you 0.049. So, if I get, I know that T equal to C V T by H square, and H for the lab actually 18 by 2, that is 9 millimeter. So, if I put here, then you will get a time factor is 0.49. So, let me 0.49 will be equal to C V into T is a 5 minutes, and here actually H equal to 9 millimeter square. So, from here actually we can get C V equal to 0.49 into 9 square divided by 5. So, that gives you 0.049 not so this 0.7938, it is millimeter square per minute. This is the CV value I got from the information given from the laboratory test results. I got the CV, and now in the field case 1, that is drained one side only, suppose drained one side only. So, suppose the clay layer is here and this is impervious and this is a 20 meter. So, H become 20 meter. So, I can find out again there also same thing I will apply T equal to 0.049 equal to CV and T suppose unknown divided by H equal to 20,000 square. So, from here I can get T equal to 0.049 into 20,000 square divided by CV, that is 0.7938. So, if I do this, then I will get answer will get in minute, that is actually 6172839 minutes, and if I convert in year, it become 11.7 years. So, this is the way, and where actually you mostly do mistake here, actually a laboratory sample thickness is given in millimeter and the actual field soil thickness is given in millimeter, and coefficient of consolidation is also millimeter square millimeter. So, to make dimensionally correct, this meter has to be converted in millimeter. So, that is what, if you do not do this conversion, if you write 20 here, then everything will be spoiled. So, you will not get the correct answer. So, this is the one case that we drained one side, but if I want to do next one, drained in both sides. So, drained in both sides, that means the same one, draining here and this is 20 meter. So, your H become 20 by 2, actually 10 meter. So, here also I can do 0.049 equal to CV, actually 0.7938 into T is unknown and H is here 10,000 square. So, it gives you T equal to 0.049 into 10,000 multiplied 10,000 square divided by 0.7938. This will be in minute, and if you convert into year, then it will be 47 years. It will be sorry, this is I have done drained in both sides, it will be 11.7 years, it will be 11.7 years, and if I the same whatever I have got in drained in both side, drained in one side, this is drained in both sides 11.7 years, and drained in one side, that will be 47 years. I do not know whether I have done mistake there. Let me see. No, this is wrongly I have done. This is actually drained in one side. This calculation I could do, it will come in 47 years. So, this is the way actually you have to do. So, that means two alternative. One is if I make the observation and I take T for both the case equal, then I will get T by H square equal to T by H square. So, the T lab by H lab square equal to T field by H field square. That relation if I use, that is one step calculation, and if I do not consider that, I will just from the laboratory information I will get the I will get this CV, because degree of consolidation is known. So, T versus U, actually there is a chart available, you can refer when U is 25%, what is T, you can collect from the chart. Otherwise, this is the equation available, we can always use for calculating the T. This equation is valid for T U up to 60%. So, since it is 25%, I have used this, and if the U become more than 60%, there is another equation that has not come. So, I have not used that one. So, based on that I get the CV value, and once I get CV value, then I know I will apply to the field calculation, that I know the 25% degree of consolidation has to be achieved. So, corresponding to that 25% of degree of consolidation, time factor is this is known, and then CV T by thickness square. So, T is the only thing unknown, from here I can find out. So, this is the way one can do, and so this is the when drained in both sides is 11 years. So, like that I can do the problem in both ways. So, either you do the observation and use the formula, otherwise I can do based on laboratory information, find out the soil parameter, and that soil parameter apply to calculate the field time, time consolidation. So, this is the way can be done. Okay. So, here actually you can see the layer was drained on both surfaces. Actually, while solving I have done reverse. So, please make a note, while solving I have taken this as a second case and this has taken 5 case. So, first case. So, reverse order I have solved, otherwise I have written clearly drained one side, drained both side, whether it is 1 or 2. So, carefully you should see that. So, next is next problem. You can see a 19.1 millimeter thick clay sample, 19 drained both at top and bottom, reached 30% consolidation in 10 minutes. How long would it take the sample to reach 50% consolidation? Okay. So, this is the one question is there. So, sample thickness is given 19.1 and drained both side, it is also mentioned, and 30% consolidation reached in 10 minutes. So, now suppose I have to estimate, I have to go up to 50 or 60%, how much time I had should spend, that to be estimated. So, that one actually you have to find out. So, for this the problem can be solved like this. You can see for the laboratory 30%. So, U is 30%. Either you can refer T versus U curve or T versus U chart, or you can take T 30 equal to pi by 4 U 30 divided by your 100 square. This is the equation up to 60%. So, it is pi by 4 multiplied by this is 0.3 square, and this gives you a value equal to 0.07. And so, 0.07 will be equal to CVT by H square, and H here H will be equal to 19.1 by 2. So, this will be equal to 9.55, because sample thickness was 19.1 millimeter and it has drained both top and bottom. So, this is the thickness. So, if I put this, so this will be equal to CV into T is actually 10 minutes. So, that will be 10 divided by H is actually 9.55 square, and from this you will get CV equal to 0.6384 millimeter square per minute. And now, I have to find out how much time is required to reach 50%. So, U is 50%. So, T 50 will be how much? Again same thing, pi by 4 into 0.5 square, that gives you 0.197. So, I can find out 0.197 equal to C V 0. Same soil 6384 into T is unknown and H is again same, that is actually 9.55 square. Okay. So, this information, initial information, from the initial information I got the C V, and then to find out the second condition I use that C V. So, if I do this, from there actually we will get T equal to 28.1 minute. Okay. So, this problem almost similar to that which we have done in the say alternative method. Okay. So, the first calculate the C V, then apply that one to find out the time. So, now this is the second problem is done. Now, let me see one more problem. So, this is a problem given, you can see the results obtained from a consolidation test on a clay sample for a pressure increment of 100 to 200 kilonewton per meter square, where this is the table actually is given. You can see when thickness is this much, the time is this, time is this, and then with different time thickness change is shown. Determine the coefficient of consolidation of the soil, and then after that you can see how long would a layer of this clay 10 meter thick and drained on its top surface only take to reach 75% primary consolidation, and then if the void ratios at the beginning and end of the increment were 0.94 and 0.82 respectively, determine the value of the coefficient of permeability. So, time versus thickness data is given, and that means you have to first find out coefficient of consolidation. What can I do? I can do root time method I can use. So, if I use the root time method, from there actually I can get T 50, okay, and then T 50, from there I can equating with time factor 50% time factor. So, I can get the value of C V. So, that way actually first calculate the C V, and then applying that C V I can solve the other part. So, let me see how to do this. You can see you have to plot, first you have to plot thickness versus square root of time, that you will get, and from there will corresponding to root T 90 will get T 50 will sorry not T 50, you will get T 90 here, will get root T 90, root T 90 will get from here, and from there we will get T 90 actually. So, if I plot this root time versus thickness, I will get root T 90 actually it is equal to 6.54. So, from there actually T 90 will be equal to 42.7 minute, and mean thickness equal to 12.168 plus 11.8 divided by 2, that is top at the end and the beginning it is 11.984, and so 11.984. So, H will become 11.984 divided by 2, that is 5.992, and then I can find out C V equal to T 90 into H square divided by T 90. So, this is the formula, actually T 90 equal to C V T by H square. So, since I need C V, I express in terms of C V. So, T 90 actually from the graph I can find out T versus U plot, I get U corresponding to 90%, T 90 will be equal to 0.85, 0.85. So, I can put 0.85 into 5.992 whole square divided by T 90 actually 42.7. So, if I put those, then I will get this one will be 0.715 millimeters square per minute. And second part actually for a same soil, suppose for a same soil for 75% consolidation. So, U is 75%, then T will be equal to T 75 will be 1.781 minus 0.933 100 minus U, because this is above 60%, this is the equation to be used, and if I use this equation you will get T equal to 0.48 and drainage path length 10 meter, because one side drainage. So, in the field drainage path will be equal to 10 meter or equal to 10,000 millimeter, and then T 75 will be equal to T 75 into H square, that means divided by C V, that means 0.715, that gives you T 75 equal to, if I this will be in minute, then if you convert T equal to 128 years. And there is a third part, that is d by A equal to d by dP, which will be equal to 0.94 is given thickness and 0.82 into pressure divided by 100 over this much pressure. What is the change in void ratio? It is 0.0012, and then E equal to average E will be equal to 0.94 plus 0.82 divided by 2, that is equal to 0.88, and so M V equal to your A by 1 plus E. So, A is already known, E is known. So, if I put those values, that is 0.0012 divided by 1 plus 0.88, that gives you M B equal to 0.000638 meter square per kilonewton. I had to convert the unit accordingly, and then K equal to C V gamma W M V, and all three values are known. Gamma W take 9.81. So, if you put all those values, then you will get this calculation will get 4.48 into 10 to the power minus 6 millimeter per minute. So, appropriately when you use those values, appropriately you have to use the your unit, so that I will get in this unit. Okay. So, with this I will I just stop here, because 3 problem I have taken. So, I will see some more problem maybe in the next module. Thank you.